Part 2 of our Pic-A-Star build. We're going to go over, we're going to actually start putting some stuff on. I thought I'd start out by building the buzzer and then the first section of the one of the main boards. But before I did that, I wanted to kind of show you a little bit. Here's a lot of the parts that we've gathered for this. We've got our resistors. I've got a box separated into capacitors, and here's some other miscellaneous components. I was able to source some of the Tokyo forms here. We have to rewind those, however. All kinds of goodies in there. So quite a few parts are going to go into this, and I've also got a bunch of surface mount resistors and capacitors. I've sorted them into these small boxes here by size. I've still got a little bit more sorting to do on that, but there's quite a few capacitors, so I thought I'd give you an idea of what all is going to go into building this unit. As I said, the first thing we're going to start doing is building the buzzer unit. It's this little PCB here. This little components can be used to test each stage as we get it completed. So obviously what I have to do is I've got to remove these small PCBs from this larger one. What I'm going to do, the way I'm going to do that is I'm going to go ahead and use my little Dremel tool and cut those off and clean them up, and hopefully it'll turn out really nice. That made quick work of it, and I was able to clean the board up, the edges real well, so we'll start placing components on it. While not perfect for my first attempt, see if we can get it to focus here, I was able to get it soldered in there. It's a little bit crooked, but it appears that everything's lined, or everything's connecting properly. I ran the flux along the sides before, and then just drug the solder after I soldered down pin 1. Then I drug the solder along each side, and it seemed to work okay. So we'll move on and get some more of the components mounted, or try to do some of the capacitors and resistors next, or try to do all the surface mount first and then come back and do a few of the through-hole components. While not perfect, let's see if I can get it to focus here. It turns out that the SMD soldering isn't as hard as I thought it'd be, so we'll go ahead and finish this up and see if we can't test the buzzer out. I have the beeper, or the buzzer, working now. For those of you that are building this, thought I'd try to give you a little bit better idea of how things are hooked up. Here's my switch. You have your NO contact, your NC contact, then down here at the bottom you have your common contact. The NO contact, your positive lead from your battery goes to the NO contact, and then from the NO contact comes down to the circuit board where it says NO. Then your NC contact comes down and connects to the circuit board where it says NC. Your common comes down here, goes in the one that's marked common down there. Then your red wire goes to your buzzer. It's the big round one here. Then on the black, you have the black coming from the battery that goes here where it says ground, and then you have another wire that goes from ground and goes to the actual buzzer up here. Okay, and then your two leads down here, doesn't make a difference which one they are, clear down on the end. Make sure you can see that, but clear down on the end of the board, and they're marked probes. Those I've got going up to my 2 banana clips for the probes. Now, when I made this, I don't know what I did, whether I blew the 2N7000 transistor, or on the instruction sheet here, it says in very plain English that capacitor C2 on the schematic, the polarity is reversed. Also the diode on the, excuse me, not on the schematic, but on the board itself. Also the diode D1, that the polarity is reversed. Well, I read that and then promptly forgot it and hooked those up wrong. And what would happen was when I'd hit the switch, I'd get power for a little bit and it'd only stay on for about 20 or 30 seconds. They'd go off. And when you push that switch, you're supposed to be able to push it once to turn it on, push it once to turn it off. And then this is designed to shut off after a little while. So I finally ended up replacing the 2N7000. I bought some spares, replaced the 2N, excuse me, down here, the 2N7000 transistor after messing with the value on the capacitor, and the only capacitor I had was this small electrolytic that was a 4.7 UF. I tried a 1 UF on there, and it didn't make any difference. I tried a couple different capacitors. Finally changed the transistor out, put this capacitor on, and as you see, it comes on and stays on, and if I push it again, it shuts off. So I got past that, but I wasn't getting any sound out. So what I finally ended up doing is turning on, and I took my little solder probe here, and I pushed on these leads, and I finally came to this second lead on this, pushed down on it, and voila, it started working. So I didn't have that soldered properly. Once I soldered that properly, now when I turn it on, shorten my probes across, I now get sound out of it. One of the casualties of not having a local Radio Shack, I was originally going to use one of these little small boxes I found to mount everything in, but because of the size of that switch that I ended up getting, I couldn't fit everything in there. So I went out to the local hardware store. We have Menards here, and I found these little storage boxes. They're kind of cool. They twist and they twist and hold together. But anyway, I drilled some holes in the top of that, and then I just dropped the stuff down in here and twist it on and mount it, and it works pretty good. So we're finally to the point where we can move on and start assembling the first part of the circuit board. That's what we'll be doing next. On Glidden's web page, he has a suggested order build, or order in which to build it. The first thing he suggests we do is build the audio amp. This is the schematic and sheet for that. What I've done is I went through and marked off that I have all the parts, which I have in my Mauser packages, so on and so forth over here. And then I went, as I marked those off as I found them, I also located them on the board itself. So next step are actually start soldering parts on, and when we get done with it, we'll do a little bit of test, and hopefully we'll have our first stage of construction completed. We have the first step of our Pic-A-Star completed. It's the AF amp. It involves these capacitors and resistors on the motherboard. This jack here. And then on the underside, there's the actual amp itself. And then there was just a couple of 0 ohm resistors there, basically jumpers. Now, a couple things I learned. First of all, when you're doing this, go ahead and put the surface mount ones on first before you do the large cans and stuff. Makes it easier to get to. Second thing on this particular, this is a P1 board, combo P1 board. This is the actual AF jack, that stereo jack. On the P1 boards, they're all marked stereo. This is the actual jack that you need to hook up for testing. This is actually the jack that goes over to the opto push to talk and stuff like that. This, I believe, has something to do, I haven't gotten to it yet, but I believe it's got something to do with the RS-232 interface. And then the other mistake I made is when I ordered these from Mauser, they only have 3 terminals on them, where the ones that you need for actually this one and this one have 5 terminals, because when you push that jack in there, it disconnects and isolates, at least on the stereo side, isolates the internal speakers. Now, if I had been fortunate enough and not put this one on here first and put it down here, this one only requires only uses 3 of those jacks, so I could have used that one I got from Mauser, but I'm not going to try to disconnect that there. So anyway, I've got that done. Or see if you can hear this, but the test is, I got a set of headphones hooked up to it. You should hear it. Well, you probably can't hear that, but or see if we can hear it here. When I put my finger across, touch the input, you can probably just barely hear it, but you get a little bit of a buzz. So I've got that part of the circuit done right. So I think we're going to end this video and move on to the next section. So for now, signing out, KB0ASQ.